Okay, welcome back to another stream. I say stream, not streaming, another video. I think this time, if I remember right, we are looking at setting up a texture sampler. Did I leave myself a to-do? I did not. Did I leave a to-do in here? Create an image view, create a combined image sampler, bind to the graphics pipeline using a fragment shader. Cool. That's all pretty self-explanatory, right? So yeah, on the last video, I think we've done a load of messing about to create a texture image and copy data into it. We've got a handle to it on our renderer. So yeah, I think we're going to need to make an image view, and we're going to need to make a sampler, and then a descriptor set and all that sort of fun to actually hook it into our what's it called? Fragment shader. So, what's the most sensible thing to do? I was thinking maybe shader is the wrong word, isn't it? Sampler. Let's go look for a combined sampler, because I'm pretty sure there was a section about all this that should hopefully tell us what we need. It is not fast though, is it? If I remember right, I think making an image view is pretty straightforward. In fact, we probably do one somewhere else, don't we? If we go image view. Alright, what about create image view? There we go. So, create image view takes a device, a create info. Oh, there's a bunch of stuff in there. And a handle onto the image view. Is any of this interesting? View type is two-dimensional. We're going to need a format. Maybe it's not that easy then. Bugger. Okay, we shall have to have a bit of a look and a think then. Now, is there anywhere I can find? Oh, that one would have done us. That will do us. Is this all about creating a sampler? Maybe start making a sampler. Right, let's do that. So let's go in here and we'll say texture sampler. And you're a Vulkan sampler. Look how easy that was. So, create samplers up here. And it looks dead simple. It can fail, so that's interesting. I guess where would it be? If I go look for transition, let's go find where we do our. This is our image stuff, is it? No, that's draw frame. Shader read only. Why am I struggling so much? Recording texture image commands. Yeah, so it is this. So that's making our. What's it called? My god, I'm really blanking, aren't I? Alright. After we've made our texture image, and I'll put a to-do in here. Texture image view. you can't use a texture image directly, or any image directly. You have to create an image view on the image. Right. Let's bump that forward. And let's go ahead and say res is equal to Vulkan create image sampler. Not image sampler, just create sampler. User take a device and a create info. So let's go ahead and say in here create info will be a Vulkan dot sampler create info. Which is to do. And pass that there. Create info. Allocator is nil. And sampler is renderer dot texture image sampler. Right. And then we'll do our normal if VK not success for res fail fatally. Don't know how you'd handle that. Failed to create texture sampler. Excuse me? Why is it unhappy? Invalid rune. It's because it's not JavaScript. You do it like that. Alright, so what goes in here? It's going to have an S-type, presumably. So S-type is equal to sampler create info. Pnex we can hopefully avoid. Flags we might need. I don't know what these filters are. If we look down here, flags a bit mask of these. Create subsampled, descriptive buffer, capture replay, non-seamless cube map, or image processing. I don't think we need any of them. Then mag filter, a VK filter value specifying the magnification filter to apply to lookups. Right. I think we want nearest. So am I just being silly? So I did expect to see something somewhere about so this whole like nearest versus linear versus other things. It's basically as you're sampling pixel values. Nearest says just take the nearest pixel. So if I'm looking at kind of like sub-pixel gradations, the value that my pixel should be is just the nearest pixel value that's in my sampled image. It will preserve kind of blocky pixel looks, which if you're doing something kind of pixelated is what you want. Linear will sort of add in with a weighting based on how far away they are, a linear contribution from all of the neighbors, I think. And so what that means, if you imagine you scale your image up, where a black line meets a white line, when it scales up, you'll get like a sort of increasingly light grey gradient between the two. So it'll make it look smoother if you're doing something that's not meant to look pixelated. I am maybe just remembering wrong, because I assumed I would see just the one thing. And I'm not, I'm seeing two things. So I'm not entirely sure what to make of that. I'm going to set them both to nearest for now, though. And see how we do. Okay. So mag filter is presumably your magnifying, and min filter is your minifying? Yeah, minification filter to apply to lookup. So in one case you're blowing an image up and making it bigger, and in the other you're making it smaller, I guess. MIP map mode. I hope there's one that's just like don't. Linear or nearest? Let's just do nearest. To make everything nearest, I guess. Address mode. Sampler address mode specifying the addressing mode for coordinates go out of bounds. So address mode. So this will be what happens if I'm sampling a texture across a surface that's bigger than the texture. And I think we might clamp to border. I'm not sure what clamp to border versus clamp to edge does. I'm looking in here. So yeah, repeat, just kind of like copy paste it. Mirrored repeat is what it sounds like. Clamp to edge specifies the clamp to edge wrap mode will be used. Clamp to border wrap mode will be used. Thank you, documentation. That's very useful. For our use case, we're basically going to try and define kind of like a pixel sprite sheet for what we want everything to look like. And then our quads will map to an exact sprite. So I don't think we need that, at least not in like the first versions of what I'm imagining. But we'll put a value in because I think you probably have to. Let's bang all of those in. MIP LOD bias. Bias to be added to this thing and a bias provided by that thing as described in that thing. Oof. That looks like a lot. Sampler.bias equals MIP LOD bias. Alright. Let's hope that we can set that to 0. What else do we have? Anisotropy enable. I think we can just set to false, which will then let us ignore that other field. So anisotropy enable is false. Compare enable. To enable comparison against a reference value during lookups or false otherwise. Default shader state if this member does not match. And then a compare op, which you will use for depth comparison. So we're not doing that. So let's go ahead and false and compare op. I'm going to put in just so it's clearly there. But I don't think we need to set it value. Min LOD. To avoid clamping, the maximum value, set it to the constant none. Max LOD is Vulkan. LOD clamp none. Border color specifies the color for a predefined border. Okay, maybe that's the difference between border and edge then. So let's go ahead and how do I do it? Do this. Let's make these all say edge. I don't think we care about border color, which I assume which makes it black, and then unnormalized coordinates. I think we might end up using unnormalized coordinates. Where are we looking here? When unnormalized coordinates is true. In fact, should we do? Let's use unnormalized coordinates for now then. So with normalized coordinates, your texture will just be referred to as like 0 to 1 in both directions. So to refer to the middle of the image, you'll use 0.5. I think, or is it -1 to 1? Unnormalized coordinate false. Yeah, 0 to 1. Whereas unnormalized coordinates is 0 to the image size in each dimension. So if I've got a 1000 by 200 texture, you'll refer to it in pixel coordinates. Which if we're imagining splitting it into sort of a sprite sheet, it's easier to reason about in those terms, I think. So I'm going to make it unnormalized. Have we set view type? Am I mad? I don't see a view type in there. The image view must have a view type, yeah. So it places restrictions on the image. Must have a single layer and a single MIP level, yeah. So that's all fine. Yes, that's all fine for us, I think. Are there any of these we didn't set? Unnormalized coordinates we've set. Border color we don't care. Values I don't think we care about. Let us see. Does that compile happily? It does. Except unnormalized coordinates is true, but min LOD and max LOD must both be 0. Okay, so yeah, you can't have LOD if you're doing unnormalized coordinates. Fair enough. That probably makes sense if you stop and think about it. Cool. That all seems pretty nice. So now we have a sampler. We currently still don't have a image view. So can we go look for create image view? Oh, let's sip of my drink. Drinking a alcohol-free Guinness because it is Friday. Gotta let your hair down. Oh, it's taking a long time to search. Okay. Let's come in here then. Bang that in there. I've moved my my key so that instead of doing Control T as my kind of leader key, I'm doing Control C because it seems like it's a Emacs convention. I think Control T is bound to other stuff, so Control T does this by default and swaps characters, which I haven't found any real use for, but I've also found, like, I think in DRED it's bound to something, so I didn't want to be using it for my leader key because it was conflicting with stuff, but it's taking some getting used to. Alright, what are we looking at in here? Create an image view, you call this. So let me bang a to-do that we can find easily, and then we will add in alongside these a texture image view. So these all kind of come together, right? So the texture image is the handle, texture image memory is the memory allocated and bound to the handle, texture image view is how we access that memory. And then the texture sampler is how we access values at positions within that image view. So it adds some extra logic on top. Alright, so we're back in here. We would like to VK create image view. VK create image view. I assume you take a device. Nope, because it's not VK, it's Vulkan. I might change Vulkan to V. I feel like I'm spending a lot of time typing Vulkan, and I keep forgetting about it. Takes our logical device. It'll take a create info that we've not created yet. We don't have an allocator. And we'll need an ampersand renderer dot texture image view for our in-out value in there. That I assume can fail. Yep, returns a result, so it can fail. So let's go ahead and say result is in there, and if it is not a success, then fatal failed to create image view. Texture image view. Right, what goes in this then? Is it image view? Again, not VK. Image view create info. You presumably take an S type of image view create info. What else do you take? a view type, I know the answer to, is 2D, or D2 in the Vulkan wrapper. Components, flags, format is potentially interesting. I think we're R8, G8, B8, A8, uint. Can I check that somewhere? Would it be up here? Command pipeline. Image memory barrier count. Is it on the image memory barrier? Transfer. I don't think so. This is really referring to the layout in memory, whereas we're talking about of the 32-bit number that is a number, or that is a colour. How are those channels defined? So I don't think it's that. Is it on this? Buffer image copy, image sub-resource. I'm sure there was something. Is it actually on the original image? I think it might be on the original image. Yeah. There we go. So, R8, G8, B8, A8, uint. Uint just means I think it'll be values from 0 to 255 rather than minus 255 to 255? No. Minus 128 to 127, I guess it is. So we're in here. Flags, we've got the image. So you are renderer dot texture image. Flags and components and sub-resource range. I don't know what we put for any of them. Let's bang them in quickly. And actually, we had a look. We do have these elsewhere in this program. So let's go and do a search for image view create info. What do we put in these other ones? We had no flags. Component is R. In fact, we might just nick this. Let me make a new line so I don't collide. Flags we set none. That we get rid of. That we get rid of. Components. I actually don't know what that does. I'm kind of curious. Have a look. Components is a VK component mapping structure specifying a remapping of color components or of depth or stencil components after they've been converted into color components. Alright, I don't feel like it told me anything. I think what it's saying is that our format tells us what byte we're associating with each channel, so RGB and A, and then this will let us define a mapping, so we could then manually say, actually, I want to swap R and B, or I want to, I don't know, like half R, or something like that, I guess. Don't really know. But identity, presumably, is what we want for simply read a thing and do nothing to it. There we go. So, I'm going to do a quick commit there. What have we done? Create texture image view and create texture sampler. Because at that point, it feels like we're close, right? This is where you naively think, like, we've got all the bits. How hard can it be now? I think there's a deceptive amount left to do still. Is there an easy way to see, like, anything in here about samplers? There is. I assume, actually, this is all about making the sampler. Where would I have to go? We call it descriptor layout, resource descriptors, maybe. So what is this? A descriptor is an opaque data structure representing a shader resource, such as a combined image sampler. They are organized into descriptor sets which are bound during command recording for use in subsequent drawing commands. Arrangement of content in each descriptor set is determined by descriptor set layout. Yes. If the descriptor buffer feature is enabled, the implementation supports placing descriptors into descriptor buffers bound during command recording in a similar way to descriptor sets. Which I don't think is us. Does this break this down any further? No. Okay. So we skim down this. There is one of these that is a combined image sampler. There. Which is what we want. Is a single descriptor a single descriptor type associated with both a sampler and an image resource, combining both a sampler and sampled image descriptor into a single descriptor. If the descriptor refers to a sampler that performs all of this stuff, the sampler must only be used to sample the image in the same descriptor. Otherwise, the sampler and image in this type of descriptor can be used freely with any other samplers and images. I think that's fine. What is this thing? On some implementations, it may be more efficient to sample from an image using a combination of sampler and sampled image stored together in a descriptor set in a combined descriptor. Okay, so you might want to do it the other way, but if we can have just one thing, we might as well have just one thing. Right. So we keep coming down. Descriptor sets. Descriptors are grouped into descriptor set objects. A descriptor set object is an opaque object containing storage for a set of descriptors, where the type's number of descriptors is defined by descriptor set layout. The layout object may be used to define the association of each descriptor binding with memory or other implementation resources. Layout is used both for determining the resources that need to be associated with the descriptor set and determine the interface between shader stages and shader resources. Right. So we need to define a descriptor set layout. Should I actually pull this alongside this? Hopefully that's not too unreadable. Make that a bit smaller. Hopefully that's still readable. Right, where are we up to? So we've created our sampler. We're going to have to make a descriptor set. And a descriptor set layout. I think this stuff might want to go live next to all of our actual, like, graphics pipeline stuff. Because I think it's related to that and may have more stuff added to it later. Create synchronization objects. D-init. Where's our graphics pipeline get made? Ah, there. So, let's do something like create descriptor set layout. And let's baby step this. So we're in here. We want to create a VK descriptor set layout. Alright, I'll tell you what I'm going to do. Is I'm going to put these all on our... oh my god, what's it called? On our renderer. At least at first. And then if they're only needed in the one place, we can make them local later. But I think this can just make it easier for us for now. To just bang something out. So descriptor set layout. And then let's get back to our to-do. Right. It has a result. It has a create info that we'll have to create. So create info equals Vulkan descriptor set layout. Let's have a bunch of stuff in it. Res vk create descriptor set layout. Take a renderer device. Create info nil and a pointer to our is it just called set layout? No, that's the name of the variable. Maybe I'm too tired. Why are you unhappy? Because you don't live in there, you live in there. Wrong type. Create info. Presumably has an S type on it of descriptor. Descriptor set layout create info. You can see why you need a autocomplete to do all this Vulkan stuff. There's so much guff. Oh, have I missed the create info? There we go. Has an S type, P next that we hopefully don't need. Flags. Specifying the options for creation. Let's have a look at them. What options do we have? A whole bunch. Descriptor buffer embedded. Host only, host only. Push descriptor. Update after bind. Yeah, I have no idea. So, if we don't know what they are, let's hope they're nothing. Binding count, which is currently 0, and P bindings is currently 0. I'm going to guess that will blow up. Or at least will complain. It doesn't complain. I guess it doesn't complain because... Oopsie daisy. If this is one that's 0, that makes sense. So if I come back in here... Oof. We run you again. And in that case, if binding count is not 0, it must be a valid pointer. Cool. What is a binding? I think a binding will be the thing that says we want this combined sampler. I guess. Create flags. There we go. So descriptor set layout binding. Binding is the binding number of this entry and corresponds to a resource of the same binding number in the shader stages. So, can we have a look in here? Can we make a texture combined sampler binding, which will be a Vulkan descriptor set layout binding. I'm going to guess these go from 0, so I'm going to just put a 0 in. A type that I'm assuming is combined image sampler. Yes. A count. Why do we need a count? Descriptor count is the number of descriptors contained in the binding, accessed in a shader as an array, except if descriptor type is inline uniform block, in which case descriptor count is the size in bytes. If it is 0, this binding entry is reserved. The resource must not be accessed from any stage via this binding within any pipeline using the set layout. Okay. So I guess we're a descriptor count 1, because it's just the one of them. Stage flags. It's going to be one of these. I think it's going to be just fragment shader. Bit mask of bits specifying which pipeline shader stages can access it. If you use all, it's shorthand specifying that all defined shader stages, including any additional stages defined by extensions, can access the resource. If you don't include one, then a resource must not be accessed from that stage via this binding. If one's not included, it must not use it. Other than input attachments which are limited to the fragment shader, there are no limitations, yada 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 yada. Cool. I think fragments are all we need. So that should do us. Then there's a mutable samplers thing I think I saw before, and I didn't know what to do with. So mutable samplers affects the initialization of samplers. If descriptor type specifies a combined image sampler, then this can be used to initialize a set of immutable samplers, which are permanently bound into the set layout and must not be changed. with immutable samplers does not modify the samplers. So I think we're going to set that to nil for now. It does sound like something we could do later. I don't know if there's any performance gain to it. But I don't know. We're so many steps in, having not seen anything work yet, that I'm kind of keen to not for now. What does it say? The above layout definition allows the descriptor bindings to be specified sparsely, such that not all binding numbers between 0 and the maximum number of binding needs to be specified in the p bindings array. Bindings that are not specified have a descriptor count and stage flags of 0. Okay. That's not us then. However, all binding numbers between these may consume memory. Cool. Maximum binding number specified should be as compact as possible to avoid wasting memory. Thank you. Pnext can contain one of these things that I'm hoping we don't care about. Binding flags, create info. I think there's something about needing a pool, like another memory pool for descriptor sets. But I'm not entirely sure where to look for that. Oh, what is this? The following example shows a shader snippet using 2 descriptor sets and an application code that creates the corresponding descriptor set layouts. So you have a set, you have a binding, you have your uniform sampled image. Right, and then you have a binding 1 referring to the other one. And then the spurv. You make a binding. You make another binding. Ah, gotcha. You'd make one for each. Yeah, of course, that makes sense. Sampled image, uniform buffer, descriptor set layout, create info. First descriptor set with the 2 bindings. And for the other one. So if we come back and look at our code. Oh, why have we got a complaint? Is that something we've just done? No, okay, it was an old one. Create descriptor set layout, which we are doing, right? Create descriptor set layout, yes. So that's all good. We've not been very disciplined about destroying things. I'm kind of just going to live with that for now. A pipeline layout. Access to descriptor sets from a pipeline is accomplished through a pipeline layout. 0 or more descriptor set layouts and 0 or more push constant ranges are combined to form a pipeline layout object, describing the complete set of resources that can be accessed by a pipeline. The pipeline layout represents a sequence of descriptor sets, with each having a specific layout. This sequence of layouts is used to determine the interface between shader stage and shader resources. Each pipeline is created using a pipeline layout. I think we probably have a pipeline layout in here somewhere. So let's go have a look. Pipeline shader stage create. Stages. Is there a quicker way of doing this? Can I look for create pipeline layout? Yes. So we already have one. I'm guessing it's set layouts we're going to care about, is it? To create this, you do that. Create info. Pipeline layout create info is here. Set layout is a number of descriptor sets, including the pipeline layout. So we're going to increase you from that to that. And we're going to have... you a pointer? You are a pointer. Ampersand renderer dot descriptor set layout. So lots of room for that to get more complicated, but Hopefully fine. So is any rest of this interesting to us? Flag, set layout, and set layouts. We've not got any push constants, so that should be fine. Oh, I'm yawning. Oh. Cool. That passes it into our... what do we call it? Graphics pipeline. So it should now exist in our graphics pipeline. We might be able to see it in RenderDoc. I think we should go have a look. So you, sir, get created, and that's all well. Can I remember how you do a shell command? Can I do like, it's not that one. What have I actually done here? Whoops, descriptor set layout is fine. That one. And I would like to do Odin, build, main, debug. You just do like out main.bin. Is that how you do it? File main not found because we're in the wrong place. Okay, let me instead go just do it from a terminal for simplicity. So we're in here. Odin build main, out main.bin, debug. It's not in there because it's ignored like it should be. We check it runs fine. Let's then do RenderDoc. We would like to launch binary main.bin. We launch it, capture a frame to look at, close this. We have a descriptor layout. I have an image view for the swap chain image. Do I have a combined image sampler? Command buffer, command pool, descriptor layout. Which is in there with a device, fence, graphics pipeline, image view. No, I still don't see one. Baked command buffer. So these are going to be our index and vertex buffers, command buffer and command pool. Any way to see what these are pointing to? Bindings count 0 on the descriptor layout. That doesn't sound right, does it? I got something in here that's saying it's a 0. So we have a pipeline layout, which is being passed into our create pipeline layout, which is what we're looking at here. That should be setting it to this. VK descriptor set layout binding. VK descriptor set layout binding 0. I'm not sure what that's telling me. Pointer to bindings is 0. Binding count is 0. Doesn't sound right. But I don't actually know how to check that. Other than, I guess, should we just go try plumbing it into our shader and see if it works? I can't think what we could be doing wrong there, because I'm looking at it. And set layout. Ah, that was the bindings. So to the descriptor set layout, can we get references to you? Where are you set? You're used in there. Right. Binding count 0. Because we're not passing it in. Hey, good thing we checked, eh? So binding count should be 1. You, sir, are a texture combined sampler binding. And is it an issue that goes out of scope right away? I don't think so, because we then send it over to the graphics card, so it shouldn't matter. Right, let's try that again. Aren't you glad we checked? So Odin, do the build. RenderDoc. Let's run the thing. And resource inspector. Does it look different? our pipeline layout down here now has a binding to a combined image sampler. Can we go to it? A combined image sampler. Device, fence, graphics pipeline, image view, with our image view for the swap chain image. Memory, physical device. Oh, where's that two physical devices? Weird. Pipeline layout. Queue, semaphore, shader module, swap chain. Okay, so we're still not seeing it in the resource list. I guess maybe it's just that it's clever and it knows that it isn't used, but I can see it now in there, so that's good news. Alright, let's go work out how we put that bad boy in our GLSL shader. Now, I don't really know anything about GLSL, and so I'm quite tempted to just look up the old tutorial that I used. Although maybe we can pick it out from this. So, layout set is the index into the descriptor set, binding, and then let's just try that. So if we go to our fragment shader, a long time since we looked at these. Can I just do layout? Set is 0, binding is 0. Uniforms is the same in everything. Texture 2D. Sampled image. And then how does samplers work? Where's his... Oh, does he have any code that actually calls it? Doesn't look it. Okay. Let's see if that will build. Did I make a build shaders for that? Oh, no, it looks like I didn't. Unless it's in there. Oh, how do I build shaders? GLSLC. Hey, we've done this. Okay. Good going, Matt. Output. Vert. Frag SPV. Shaders, main frag. Attempt. Unexpected layout, expecting comma or semicolon. Okay. That looked promising. Let's see if we can just suss this out ourselves then. So how do I use, if I say GL, SL, sampler. How well documented is all this? Texture lookup functions. Flat in, first data, you just do texture, some sampler, coordinates. You do texture, some coordinates, and sampler. Okay. What actually are my coordinates? I have no idea. So presumably I want out color is texture on my sampled image. I don't know what my coordinates are meant to be. Okay, we're going to go just cheat and look at what we were doing in my Brackeys project, because, like I say, I'm not super read up on shaders. That would be fun to get good at, but we're not there yet. That I don't think we need yet, because I think we're going to need that when we have multiple of these. Like we have a... You see how here this one is a... Layout binding, it was 0. There's a list of these. Tech coord. Ah, right, we passed that in there. Interesting. Oh no, I can't remember how to use all my bindings in this. And I can't use them because I'm not in Tmux. Oh no. Okay. So we're going to have to pass in an in variable text coord. We don't need a text index. So text coord, let's do that. Let's split these up again. So layout and location is 1. We have an in vec2 texture coordinate, which we'll just pass through. And then we're going to call texture, text sampler, text coord. So texture, sampler, in fact I like that better. Let's call text sampler. You're going to be text sampler. I gotta forget everything. Text coord, and that should be it because we're not using that function. That will require a change to our vert. So shaders main.vert. You're now going to have an extra layout. Location equals 1. Out vec2 text coord. And what actually is your value? So let's go look at our vert shader. Out is text coord out. It just passes the value through. Interesting. What do we do with that information? Right. Let me go tmux new t brachy. So we can go cac. What do we do? So we're in here. Maybe in main. Where's our vertex stuff all defined? Are we main or renderer, wasn't it? In fact, let's be smarter about this. Can I rip grep for vertex? I can. What value were we passing in? Which of these looks useful? 35, so they're all in renderer. So let's look in here. Vertex has all this stuff on it. What is this? Vertex input, binding description, binding 0, stride, input rate, vertex input, attribute descriptions. That's the one. Right, but where do I get my vertex? Who's setting these values? That's what I want to know. So one of these for get references are for list symbol references. Didn't work. We have a back buffer, so that's not it. Oh my god. Why don't I remember how this works? Can we do a search for... No, we're in the wrong file. Can I do text pos? Can I do rip grep for text pos? Offset equals cast. Offset of that. That's not useful. Oh no, I can't remember how this works. Util, game, overlap, animation maybe? Aha. Ah, no, okay, I remember now. Yeah. We have to associate each vertex with a point from the texture. Because we're not doing normalized, those points are... Yeah. Okay, so we're going to need to do that eventually. Can we just hard code that value now, though? Bail out of that. Cac. Oopsie daisy. Where's my shaders live? Shaders. Shader dot vert. You just do value equals thing. So I can totally come in here and set, instead of frag color, text coord equals a vec2. What can I do with that? In position is my position on the screen. Can I just pass it in position? Can we just try that and see what it does? Let me exit out of view. Let me do another GLSLC. Cannot open main.frag. Where are we? I'm not in the right place. Mine. Flectris. Texture. No matching overloaded function found. Text coord. Unidentified. Cannot convert from... Ugh. Okay. Can I make my vert at least? But that one's unhappy. Error text coord. Okay. So frag. That's why. Alright, so it's one of them. Texture. No matching overloaded function found. That looked like it was what I did in the other one. That didn't work. How do you use texture? Texture, some sampler, texture coords. GLSL samplers, texture type, 2D texture, language definition, sampler 2D texture 1. Void function in sampler my texture 010 size. Texture accessing is not limited to that. Where do you get used though? Why can't I just call texture? A. There's something I was meant to include. Texture equals a load of stuff. Texture equals a load of stuff. Some sampler and coords. How do you work? Binding textures to samplers. Sampler types are using this. So void, active texture, bind texture. So these are the OpenGL calls to set it up. So that's not us. Diffuse text is not us. I don't think any of these are us. Alright, let me go look up. What even was the tutorial I used to use? That looks right. Texture mapping. Combined image sampler. Shaders. So they are doing more than we're doing. And their fragment shader. Used to look like that. Vec4. Frag text coord. Sampler 2D. Text sampler. Out color equals these things. Out color. Is that my problem that I'm doing both of these? Can I comment that out? How do comments work in GLSLC? Is it like that? No matching overloaded function found for texture. Does look like none of them do this business. Error texture, no thing found. Void text sampler, which is that. Frag text coord. What's the types on frag text coord? Yeah, it's a V2. And ours is a V2. Alright, let me Google the error I'm seeing. GLSLC, this. GLSLC, that. Trying to read 2D sampler using 3D coordinates. Is that going to be me? 10-year-old, we love that. Here's a bunch of stuff. Frag pos, texture coordinates. Calling texture. Material.diffuse, which is a sampler 2D. Diffuse, I guess. Text coords. His is a Vec3. Does slicing off the Z help? Change the texture lookup from that to that. Oh, I'm so confused. This just looks like it should be working, right? So where are we? GL position is equal to Vec4 from in position and all that stuff. Texture coordinate. Frag color texture coordinate. Why won't you build? Layout location 0 out Vec4 out color. Oh, this is going to be the most boring video. It felt so close. Ah, texture 2D. Are you not called texture, you're called sampler 2D? That would have blown up though, surely. I'm willing to bet that's going to be it. You should be called sampler 2D, not texture 2D. Let's try that again. Hey! Oh, thank God. And let's check you're also compiled. Odin, build, all of this stuff. Main.bin. Okay. It's hanging. Oh. Okay, fun. It statically uses descriptor set 0, but because the descriptor set was never bound, the pipeline layouts are not compatible. If you're using a descriptor, make sure to call one of bind descriptor sets. Etc. for bind point graphics. Can we look that up? What's it called? VK command bind descriptor sets. We've missed something. You have to do it inside the command buffer. Alright, we're moving again. Sorry, my throat keeps frogging up on me. So let's see. This will be back in renderer. This. Oh, command buffer, pipeline bind point, pipeline layout. Is my pipeline layout available outside of create graphics pipeline? I don't think it is. It is not. So move to renderer, maybe? Where do we call this? I'm confused that it's in the graphics pipeline, isn't it? the graphics pipeline create has our layout on it. Is there anything in this? No. I guess, is this the sort of thing that used to happen on the render pass and now it's all done in commands, maybe? Alright, either way. What does it mean? If we go to... Oh, what's our function called? It's not that one. It's not create graphics pipeline. It's none of these. It's in here. So before we do the submit, before we do the draw, we're in here. And we want to do Vulkan command bind descriptor sets. So hook that in. Pipeline bind point. Oops. What does that mean? It's not in. Pipeline bind point. Is graphics. Our layout is what we're going to struggle with. We're going to have to do renderer dot something. First set will be 0. Descriptor set count will be 1. Pointer to descriptor sets we can do. Is renderer ooh. Do not understand. Alright, so that's going to have to be renderer dot something as well. Dynamic offsets is the number of dynamic offsets in that, and a bunch of offsets that we don't need. So we can go offset count 0 and P dynamic offsets is nil. So we're going to need a pointer to our descriptor set and a pointer to our pipeline layout. Let me stick another to do just so we can get back to here quickly. I don't think we have either of those on here, do we? We have a descriptor set layout. So I guess we're going to want our descriptor set in here as well. Vulkan descriptor set. And I'm going to need a pipeline layout, I guess, in here. Vulkan dot pipeline layout. Right. I think... Oh, we don't create those both in draw, do we? We make one in here. So let's go look for descriptor. Is this right? We have the binding. We have a descriptor set layout binding. We never make a thing just called a descriptor set. Is that wrong? Or do we do it inside of this? Descriptor. That we don't seem to be calling anywhere. I said I thought we needed a pool, didn't I? We're not done, boys. We are not done. What is this? Descriptor pool, create info. A descriptor pool maintains a pool of descriptors from which descriptor sets are allocated. Externally synchronized, meaning the application must not allocate. Right. What do we do with that then? Well, this we do want to move to renderer. So let's go ahead and do that quickly. So I think we can do that very quickly. Then let's see. Do we have any other errors to tidy up? It doesn't look it, does it? Oh, okay. I've broken it by putting things that say something in them. So layout, I'm going to call pipeline layout and renderer dot descriptor set. How I already added that? Alright, so it's defined and it's used, but it's never actually set. If I try and run pipeline layout, I'm doing this a dumb way. Jump to there. Layout equals render.pipeline layout. There we go. And that'll blow up because it doesn't have the things available to it that it needs, but it doesn't blow up quickly, does it? It really tries. Cool. Command bind descriptor sets does not exist. Pipeline layout was not created. Vulkan spec states if the graphics pipeline library feature is not enabled. Yeah, so we're not doing any of that. Get out of here. Alright, so we need to go and create a descriptor pool. Where do we make our command pool? Can we go and do it like here? No. Here. Descriptor. Damn it. Descriptor pool. Which is a Vulkan dot descriptor pool. Right. Where do we make our command pool? There. Allocate to command buffer. Can we say in there next to it, create descriptor pool? And we will say in here that it has a create info, which will be a Vulkan descriptor pool create info, which we'll have to fill in. That will get us a result, which is from Vulkan dot create descriptor pool. We'll take in a renderer device. Take a and create info. Take an allocator and a pointer to our descriptor pool. If VK not success, then be fatal. Maybe I should have made like fatal if not success, but hey ho. VK fatal failed to create descriptor pool. Same issue, not right JavaScript. Gotta use your big boy ones. That looks right. So we've now got a descriptor pool. We're gonna have to allocate a descriptor set, which I'm hoping we will find. Allocate descriptor sets. They take a device, and allocate info, which is down here. Descriptor set allocate info takes a pool, a descriptor set count, and layouts. So can we go find layouts? There we go. So we create our descriptor set layout, and we stick it on the renderer. Can we say in here, allocate descriptor set singular for now, right? Back to the top. It's already on there. Nice. Can we go find our to-dos? So this here is going to have an allocate info, which is a Vulkan descriptor set allocate info. And was that function that calls it? Nice and simple. Let's hope. Result will be Vulkan allocate descriptor sets. You, sir, take a device. You take allocate info. And you take a pointer to our descriptor set. So far, so good. Our allocate info has to have, as always, S-type, which is going to be descriptor set allocate info. P-next we can hopefully ignore. Descriptor pool, which will be our renderer descriptor pool. A descriptor set count, which will be 1, and pointer to set layout, which will be on our renderer, like so. Excellent. Okay, so we now are allocating a descriptor set, which means inside of here, somewhere, in pipeline layout create info, we point to a descriptor set layout. Are the right type? Yeah. We create the pipeline. Pipeline rendering create info. Color attachment. What was it called? Bind descriptor. Oh, no, I'm forgetting. Can we go find just commands? Command pipeline barrier. Copy to image. More pipeline barriers. So it's in here, basically. We bind these things. Command bind descriptor sets with this pipeline layout. First set is 0. Descriptor set count is 1. That's a pointer to our descriptor set. Do you work? Does not look happy. Computer is frozen. Oof. Okay, what is this saying? When we create it, so we go to descriptor pool. Descriptor pool. Sorry, descriptor. There we go. That sounds right. We forgot to set the descriptor pool create info. That seems fair enough. Computer. Pool size count. Can I literally just set the type? And hope? Maybe? Still no. Oh, it wants a pointer to the pool we're creating, which is fair enough. Or to the handle, I guess. Wait, what are you saying? Validation, create info, descriptor pool, over allocation. Create info max sets is 0. Okay, let's go do this properly then. VK create descriptor pool. And it chugs. Have a sip of drink again. Oof, it is not happy, is it? Oh, I'm regretting doing that now. Should we just start guessing what we put in here? Flags 0. Max sets 1. Pointer to pool sizes, pool size count. Pointer to that 0. Try that. Some allocate descriptor sets. Looks like it's complained. Allocate info, pset layouts, binding 0 was created with this type, but descriptor pool was not created with any descriptor pool size type. Oh, okay, we have to go find it in here. Anybody remember what it came under? Descriptor sets. Oh, no, I don't remember at all. Where was it? So you have descriptor sets, descriptor buffers. It doesn't sound like any of them. Oof. Maybe we Google it? Okay, let's... Where's the thing? Jump to the top. We set up here. We would like to find create... descriptor pool. Descriptor pool, yeah. Give that a minute. Did it jump? Okay, we found one. And it's not a link. That is annoying. I don't understand why all these red ones aren't links. There we go. Ah, it's under allocation. So, descriptor pool, create info. Takes all of this stuff. Flags specifies certain supported operations on the pool. So that might be useful to us. And then pool sizes is a pointer to an array of pool size structures, each containing a descriptor type. Ah. So it does sound like we need this. Descriptor counts the number of descriptors of that type to allocate. If type is that, then that is instead a load of bytes. Okay. So can I say pool size combined sampler pool size is equal to descriptor pool size type. Why is that not working? No? Okay. So, descriptor pool size is equal to a Vulkan. That would be what it was. Descriptor pool size type is a combined image sampler. And descriptor count, we will make 1. You, sir, take a descriptor pool size and you take 1. Like that. Now you run. Oh! That looks slightly more promising. We are still getting validation errors, and we're not actually seeing anything from our texture. But other than that, a success. The descriptor is being used in a drawer but has never been updated via update descriptor sets or a similar call. Descriptors in each bound descriptor set specified via bind descriptor sets must be valid as described by descriptor validity if they are statically used by the pipeline. Okay. It does tell us what function to go look up, which is nice. Where am I looking? I've lost it. Descriptors in each thing specified by that must be valid as described by that. Wrong bit. They've been updated by update descriptor. So let's look for VK update descriptor sets. Once allocated, descriptor sets can be updated with a combination of write and copy operations. Okay. 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 Where do we set up our descriptor set? So, at this point it's allocated. Yeah, I should have put that together, right? We've allocated memory, we've not written anything to the memory. Oops. So, what do we put in here? Date descriptor set. It's a function that can't fail, with descriptor write count, pointer to writes, copy count, pointer to copies. Okay. That doesn't look as simple as I might hope, but we'll see. So Vulkan update descriptor sets takes a renderer dot device, a descriptor write count writes, copy count copies, pointer to write descriptor set structures are describing descriptor sets to write to copy between the operations described by write to perform first, allowing the operations followed by the operations described by copies within each array. The operations performed in the order they appear in the array. Yada yada yada. Ooh. Okay. I think we're going to want writes, right? We're not copying between descriptor sets. We just want to bang this in. So let's say a descriptor. Oh my god. Oh no, it's just a function. So descriptor write count 1. Let me make a thing up here for descriptor writes, which will be, let's make it singular, Vulkan dot write, oh my god, descriptor set, which is to do. You, sir, take that, and then 0 and 0. How about that? Then you, oh, you take loads of stuff. Okay. Okay. Let's go look at this. So, S-type, our favourite thing. You know where you stand with S-type. Write descriptor set. P next. Destination set is renderer descriptor set. Destination binding is the descriptor binding within that set. We only have one binding, so it would be 0. So array element is this thing. Starting element in that array. In what array? If the descriptor binding identified by dest set and dest binding has a descriptor type of this. Okay, so ours is not an array, there's only the one thing, but it'll be an array in the future, I guess. So let's make U0 as well. The number of descriptors to update. If the descriptor binding identified by this is that, then it's a byte count, else is one of, excuse me, descriptor count is one of the number of elements in, okay, got you. Image info, buffer info, texel buffer view, data size. Alright, we're only writing one descriptor, so descriptor count should trivially be 1. Number of elements in P image info, buffer info, textile buffer view, acceleration structure count, a value matching the descriptor count of that thing. Descriptor type, one of all of these things. Ours is that. What do we do if it's a combined image sampler then? Is that an image for this purpose? Only one of image info, buffer info, or textile buffer view members is used according to the descriptor type specified in this, or none of them in the case of descriptor type is inline uniform block, in which case it takes information from the PDX chain, or if descriptor type is that, if the null descriptor feature, if the destination descriptor is a mutable descriptor, nope. I'm guessing we want the image one. Descriptor image info, sampler image view, image layout. Right. So let's try that. Descriptor image info is a Vulkan. Descriptor image info with sampler equals renderer dot get our sampler. Image view is renderer texture image view. Image layout, I think I've set to R8. Why has that not worked? It's not one of those. Oh, what did I make it? Is it shader something? Shader read-only optimal. And then in here, you set that to that. Still angry. Combine image sampler descriptor requires float component type, but bound descriptor format is unsigned int. Okay. I can hear, I think my daughter has just got home, and so I'm going to have to run and go be dad for a bit. We feel so very close though. Let me go grab the readme. So in here, short-term plan is fix validation layer errors. Because actually we've got that all plumbed in. It's just now we need to make it actually work. So that feels a success. Let me do a quick commit. I'll do this off camera because I need to run. But hopefully this means next time we're going to get our smiley. Right. I will catch you on the next one. Bye-bye. Okay, and I am back. Let's see if we can get this done. I've got about an hour to spare, I think. Can't remember what I was up to. I've got validation errors and it isn't working. What do the validation errors say? Do index draw, combined image sampler descriptor. In this descriptor set, in this binding, this index requires a float component type, but bound descriptor format is that. VK image view or buffer view is accessed as a result of this command. Numeric type of the view's format and the sample type operand. Okay. What do we do with that information? Can I do a grep? How does grep work in this? Grep? Sure, grep. Yeah, it's a very grep. For What am I graphing for? R8, G8, B8, A8. Got nothing. Can I do grep RN R8, G8, B8, A8? Yeah, I thought so. Snorm? Signed int, signed RGB. I guess Snorm? Is that the move? So that's in the texture image view. Try that. Sorry. Compile Odin main run, which is now in the wrong place. So we do a project compile Odin main run. Odin run main. VK sampler created with unnormalized coordinates equal to VK true. Sampler may not be used with any of these instructions. I think this might be a good sign. If we go back to our fragment shader, do you remember we did, was it this in brackies? We need to go and do the rebuild. Mine Flectris. Oh my god, what was it called? GLSLC -O frag main frag. Run it again. Okay. Nothing complaining. It's also not working. I'm not sure if that's better or worse. Let me do a build and a run from render doc. And let's see if we can spot in here. Is it just that the coordinates I'm passing through don't make any sense? Right. I have inputs. I have outputs. Oh, I don't really remember how render doc works. Go and look in the history, I guess. Color pass, draw indexed. Primitive. But I now have a texture. Can I see the texture in my texture viewer? Oh no, I don't remember how this works. Command draw indexed. Index. I bind the descriptor set. That has inside of it our image. Can I see my image somehow? FS. View contents. Aha. Okay, so the RGBs are messed up, but it is in there. Okay. What actually does our image look like? Come to here. Where actually is Smiley? Open. Main Smiley. Yeah, so it does have a shadow. It's like it's inverted, isn't it? You can see all of the dark outlines are all kind of white. Okay. So our image format is clearly not right, which we can deal with in a minute. I'm going to guess that we're just passing through bad... or like useless values for our vertices, if that makes sense. So we go through this. So maybe the right thing to do is to actually do our proper... What's it called? So what have I said? I've said make my in position the same as my... there we go. So I have frag color, text coord. So am I just seeing it clear to the border color? No, because I'm using the edge, not border. And the edges are all transparent, and I've not got transparency turned on, so that all kind of adds up. So if we look at this, is there anywhere right in the middle? Okay. It may not seem it, but I think this is good news. Right, the fact that if I come in here and I run it, we get no errors, we get no validation problems. I think means it's basically working. The problem, I think, is that we're not passing in reasonable vertex data. Can I remember? In fact, we probably do it somewhere already, don't we? Is it in here? It is in here. So, I think the right thing to do is probably a commit. So what do we have to do? We have to change our image types and our texture LOD thing. That texture to texture LOD thing, I think, is actually maybe even just a bug in the SPIR-V generation, maybe. I don't remember there being a good reason for it. I think it is just that there is a SPIR-V instruction generated that it then can't handle. And when I googled it, you can force it to get the same behavior with a LOD set to 0. I think LOD is level of detail, so it's like, again, another one of those refining things we might get back to, but we're not going to worry about it yet. So what did we do? We said fix validation errors. All right. So we can always now revert. Let's say we're in here and we want text coord, which will be a GLSL vec2. All right, because this is our UV. Why are you unhappy? You're not unhappy. Which means that now, inside of this, we're going to want another attribute description, which will be in location 2, binding 0, format R32 G32 signed float. I assume that S means signed. Offset is the offset into this struct, which we can do with this built-in. So we do all of that, we attempt to compile, it'll blow up with all the places that we need to go and update. Which is this. Can we see any information about this? It's 512 by 512. So I think our thing is going to go from 0 to 512 because we've got it unnormalized. So I think the move here is top left is at 512 0. No, other way around. 0, 512. Bottom left is 0, 0. Top right is 512, 512. And bottom right is 512, 0. So that's pushing the data into our shader, but our shaders don't recognize it yet. Sorry. So I have to go into my vertex shader, and we need to add another one of these for a text coord. Let's call it in text coord, and then that can just be our out value, like so. Text coord can be in text coord, and our fragment shader will just take that value and pass it through. Can we then GLSL C frag shader worked? Can we do vert main.vert? Didn't work. In text coord undeclared. Right. What do we miss? Oh, doing the wrong thing. So let's go to our main.vert. Typing in text coord. Build that. Odin run main. Ah! Okay. I mean, it's not right, but I can see a face. That's quite exciting, eh? Let's go fix our values. Are they in main? I think they might be in main.odin. So, what are we seeing? We're seeing it's upside down. Which means that my top and bottom are the wrong way around. So, they're fine. We swap these values like this. And hopefully, we rerun. Kill the running process, run another one. We get a right way up smiley face. Beautiful. Excellent. Alright, so there's still definitely more to do. What am I saying here? Add texture coordinates to vertex data. Drawing a badly coloured in face. Excellent. Or at least kind of good. We take kind of good. Right. Okay, I guess that means that I'm not understanding these, what's it called? Pixel positions properly. So what is there to say? That makes it look like we're reading our image in and getting the wrong values. What can we do about that? We go back into renderer. I kind of wonder if it's going to be something as dumb as like swap some of these and it'll just work. No. And it knows that those don't add up. So it does make sense that those end up being the same as each other. Can I do something like make them both the other way around? Is it going to be something silly like that? No. R8G8B888. Going to be something like when we load our image data, that we need to cast into floats now that we're storing them as floats. Buffer allocate. Create image info. What's the reason that these can't be uint again? What was it that it complained about? Is it the combined image sampler descriptor, text sampler, requires a float component type, but bound descriptor format is that? And it just spams that over and over. Okay. Vulkan spec states. Let's go. Is this useful to us? I go copy that. Let me see. That was bad copy pasting. No. Did it again. So this is the same documentation as what we've been reading. It's just format. Format dash 07753. Then the numeric type with the views format and the sample type operand. The sampled type operand is accessed as a result of this. Of the OP type image. Of the OP type image. So Vulkan combined image sampler. OP type image. So again, this is probably... Oh, this one is a tutorial. Is this the same as this? Vulkan tutorial, docs.vulkan/tutorial, texture mapping. God, I don't even know. They have bindings, they have a uniform buffer as well. Texture coordinates. Is there anything in this about format? Yeah, they just make theirs as float. And this one, format, is R32G32 float. I tried to use that. Image with RGBA components and loaded JPEG. Horrifying. First thing I tried to use. Unsigned. Norman, surprisingly, it crashed with this. With A8 it works. Tested with some other random formats. Looks like the formats without alpha are not widely supported. That's probably not me. Already been using libpng. Yada 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 yada. Change the format to sRGB. What does sRGB do? I'd be like, grab all of this, jump to the end. What does that do? Hey! Okay. That I mean, actually, does it look exactly right? If we go do recompile for all cursors, get out of here. Can we do what do I have to do? Open main / smiley PNG. No. Open smiley PNG. I mean, that looks pretty good, doesn't it? You can see, because we're doing that nearest filtering, that it looks kind of jaggedy. But like I say, I think we're going to be using whatchamacallits, pixelated, pixel art type images. So I think we want that. Let me stage that. Say fix texture colors. Push that up. And then just before we call it a night, because I don't really know what to do next, I am going to go and test that. So if I go make the things that I've set to neighbor or nearest in our sampler, if I make them linear instead, does it give us something neater looking? Or does it just not work? Yeah, you can see that looks way better, right? We're just going to compare the edges. But like I said, I think for what we're doing, can I do another one? Can't have two of those at once. Can I do a... Oh, can I remember how to do Emacs? You do an async shell command, Odin run back main. Exited abnormally. Panic. IMU fatal, fail to load texture image. Interesting. Because we're in the wrong place. Okay, let's try an Emacs again. Oops. CD. What do? You go CD back. Change default directory to there. And then do Odin. No. Because now that path is wrong. And if I swap them back and forth, you can see the jaggedy line from the nearest and the smooth line from the linear. So that's fun. We can see the difference between the two. Is there anything else fun to play with quickly? I think the other thing is this. If we set it to repeat in U and V, and then we'll need to go to main Odin, where we set all of our data up here, and let's do something like scale 512, and we'll change all of these. So 2 scale, 2 scale, 2 scale, and 2 scale. Right, then I think what we should see is we're sampling beyond the bounds of the texture, and if we've changed that to repeat, we expect to see 4 smiley faces. Ooh, it doesn't do 4 smiley faces. It's still doing edge. What does it say? P create unnormalized coordinates is true, but address mode must be clamped to edge or clamped to border. Interesting. You can't do that one. Oh, I didn't know that. Okay, well, we live and learn. So what does that mean then? Is if we put you back to clamp to edge. Yes. Main sounds like a binary, so we get rid of you. Okay. If we run that one, Odin run is being run from the wrong place because I've done the wrong one. Yeah, you see it clamps to edge. And I bet if I clamp to border instead, so what I want, clamp, should probably find it. see. If we make that clamp to border, that clamp to border, we probably just get black. We just get black because we've not defined a border colour. I think you could define a border colour. So if we're in here, border colour. What type is border colour? Is it Vulkan.border colour? So let's have a look. Vulkan border colour. Ah, it's an enum. Float transparent black. Int custom. How interesting. Can I make it 4? Can we try that? Just see what it does. Let's try opaque white. There it is. And that's also useful to have done. As you can see, the black around the image itself, that's where our alpha channel is just misbehaving, right? So that's what we need to come back and do next time, is we need to work out how to enable blending and get that black bit to show the pink through from behind. And then, yeah, I guess the rest of that is all just white because it doesn't know what to do with it. I actually don't know what that would have done if it was clamped edge. I guess the edge would then also be transparent, so just make it transparent everywhere except those lines where it's opaque white. Very fun. Excellent timing. So let's discard that hunk. Discard that hunk. Discard that hunk. Check it's doing what I think it should be doing, which is just one big smiley face. We can smush it and move it around everywhere. Oh, I'm so chuffed that's actually worked. Excellent stuff. Cool. Well, that's a happy note to end on. So, yeah, actually, before we sign off for good, so we've done that, and to do next is add blending so we can support transparency in our textures. In fact, we're getting into this one now. And now our short-term plan just is our medium-term plan, so that can just be plan. Beautiful. Right, next time we're going to look into enabling blending. I would do it quickly now, but I don't remember it at all, so I might have to allocate a good couple of hours to working out. From what I remember, it was a little bit complicated last time. I didn't really understand it. So that's something to look forward to. But we can now officially actually draw an actual image on our quad. That's like 80% of what we need for our little 2D game. So we're off to the races, guys. All right, catch you in the next one.